No. All right, everyone. I just wanted to let you know that I am going to push forward with circles for those of you that are interested. One of the things that I will say, I just got done doing an extension for Honors Honors Algebra 2, and it did also have to talk about things that dealt with circles. So it is something that will be used next year in Algebra 2 or Honors Algebra 2. It is something that is going to continue into pre-calc, and so there are going to be concepts that carry over not just from geometry but into those classes. Also, I want to make sure that those of you that not only need some of this for Algebra 2 will also need to make sure that you have the material for what will be, however they might look, the ACTs or SATs. So we want to make sure that we're still involving the information. It is not required at this point. So this is only for your benefit for the year to for what's coming up next year. For this year, please remember any assignments, including the expired no reassignments, can be finished through June 9th. If the no reassignments have been, that's a pretty good circle. If the no reassignments have expired, you can still unlock them with the coins that you have been given. You can complete them, take a screenshot of your achievement, and at that point, send that to me via email, and I will update the grade accordingly. Any other assignment that I have given, you are still able to hand that in. Just know that the email ones I grade first, and then I go assignment by assignment through Google Classroom to see if anybody has uploaded anything. So keep that in mind. At this point, anything that I introduce is not required. But again, it is an extension just to make sure that you have the material. So what we are going to have in today's video, because I did not receive any questions in my email. If I do receive questions in my email, those will be gone over first. If you have any questions on any past material and want to ask during our sessions, I will go over those first. If there are no questions, I will just expand on the new information and go from there. Anything that I give as practice questions, please remember those are not required. In fact, what will most likely happen is I will also provide the answers to the assignments. And then if you have questions on how we got those answers, you can email me. And again, we will go over those before we start anything else during our live stream sessions. So obviously, as you're looking at this, you can see that we do have we're talking about circles, and we're going to specifically concentrate on segments of circles. Couple that you are fully aware of is that a radius goes from the center of a circle to the edge of our circle. So our endpoints are from the center to the edge. We do have a diameter that goes through the center, but its endpoints are on the circle. So again, both endpoints fall on the circle, and it specifically goes through the center, is called our diameter. Now I am going to put it with the same color because we do have another segment whose endpoints are on the circle, but it doesn't go through the center. And this is a chord. Now a diameter is a chord, it's just more specifically a diameter because it goes through the center. So a diameter is a chord, but a chord does not necessarily need to be a diameter, so it doesn't go in both directions. All of these are segments because they have endpoints. Now, when we talk about our circles, the other thing that we are going to have are things that fall inside the circle, outside the circle, and on the circle. So right now we know our center of our circle we've always designated with our capital letter because that's, in fact, when we looked at our proofs, we saw that. If we have a point that falls inside the circle, that's on our interior, But if we have one that falls on the edge of our circle, that is on the circle, but we can have points that fall outside, and that's on our exterior. So you do have this interior, this on, and this outside or our exterior. So keep that in mind, that there are these three situations for our circle. Kind of like if I had a rubber band sitting on my paper right now, you'd have the on the rubber band, in and out. So what we're going to look at very briefly today is how our different segments are going to affect each other. So you will find that we have a thing called a radius chord relationship. Now, please don't forget that radius does come from our diameter. And so when we do work with this, anything that says radius, don't forget that diameter is truly interchangeable because our radius is there. Now, our first one that you're going to look at is, we have to understand that when we look at a circle, we always want to talk about that shortest distance. And we talked about it. I'm hoping right now you guys can all imagine that I'm going to do the same thing that I did 100 times, it felt like, where I'm standing in the front of my room by the whiteboard, by the smartboard, and I'm talking about what's the fastest path to get to my wall. That I'm not going to make a diagonal cut to the door, but I'm going to make that fastest path to the wall, which was our, hopefully you're all saying it, the quickest path is that perpendicular. So when we talk about the distance from the center of a circle to a chord, it is always going to be measured by that fastest path. So the distance from our center of our circle to the chord is this perpendicular. All right, and because we have an infinite number of radii, that's why this radius we could eventually extend. So when we talk about distance from the center of our circle we'll call that chord AB. So the distance from the center of our circle to a chord is always that perpendicular segment from the center to the chord. Now, what's going to happen here is, again, remember, that's because what we're looking at is our fastest path, our shortest distance. Okay, don't forget me standing at the front of the room trying to figure out how to get to the wall, and I don't want to take that diagonal. So now what's going to happen, though, is because we don't actually have a radius drawn here, there are, of course, two theorems that are going to follow. And they follow because of this relationship here. So we do have the first theorem or rule, and that is, if a radius is perpendicular to a chord, then it's going to bisect the chord. If a radius, so now what we notice is that we haven't actually drawn the radius here, we just have that quickest path. So if we actually have a radius and it's perpendicular to a chord, then it bisects the chord. And so what we have is truly this same situation. We're going to have circle X, and we are going to have our radius out here. We'll call that Y. And if we have a chord that it's going to intersect, our chord we'll call GH. If it intersects here at point P, we have that right angle that's going to show up, but now what's going to happen is it will automatically bisect, which comes in handy because what's going to end up happening is we're going to end up, because of these right angles, with right triangles and all this stuff. So then, because we can see this is in a conditional statement, you can see that if we do have if then, we can also write its converse. So if we have our circle and we have this situation, let's just draw it in a different direction. And it tells us here that it's been bisected. What ends up happening is if it stopped here, and I'm going to write it this way, given CE is a perpendicular bisector of AB, we can prove that CD is a radius. And we can do that because of our converse statement. And it would be if the perpendicular bisector of a chord, let's move this up so you can see it. The perpendicular bisector of a chord passes through the chord, then it is the radius. So it does work in both directions. That if we know it's a radius and it's perpendicular to a chord, it's going to bisect it. If I actually have a perpendicular bisector and it's going to pass through the chord, then that segment is going to be our radius. So it will work in both directions. Now, what ends up happening is we have all of these lovely right triangles that are going to show up, and that means anytime that happens, we have the Pythagorean theorem. So before I end for the day, we are going to look at just one example. And I am not going to do any proofs with you today, but oh, I keep picking this guy up and he is dried out. So we do have this chord, and we are going to draw our radius. And let's go ahead and talk about AB is 12 centimeters. And CE is 8. We're gonna work with, obviously, the way I've just done this, and because I already wrote the number 12 there, it's not to scale, so I understand that. I want to find ED. All right, so I love these questions because we get so caught up, and again, I made this up on the fly, so you'll have to, again, forgive me for it not being to scale. I love these questions because, pardon me, we get so caught up on ED being out here, and the fact that we said how much CE is, and we're trying to figure out the rest, that we fail to remember that we are allowed in these questions to put in segments that we know should exist. So for instance, the first thing I'm going to do is I'm going to take care of the fact that I can see, and I probably should have written in the given statement, that this is circle C after each one, so that we know that is definitely the center. So if I know that this has a center at C, then I do know that CD is the radius, which also means CA is a radius and CB is a radius. So I have what would be 3 radii that are pretty evident at this point. I also know that if AB is 12, and I do have a radius CD that's going to be perpendicular to this chord, that it will bisect the chord, and that means each of these pieces are 6. CE, again, not to scale, we said was 8. And now what I'm looking at is, I just want to figure out here. Well, again, if I know that that's a radius, what I can do is I can figure out what this radius is using my right triangle. So using my right triangle of 6, 8, and X, I then have enough information to figure out what would be left over for ED. Well, hopefully you've noticed that X is going to be 10 because this is a 3, 4, 5 right triangle. We just multiplied everything by 2. So this is 3 times 2, 4 times 2, that would have to be 5 times 2. And if not, you have the Pythagorean theorem that would have figured that out for you. So if I now know that CA is 10, that means CB is 10 because it's also a radius, and most importantly, CD is 10 because it's a radius. So what I'm going to be able to do is take 8 from 10, and I find out that ED is 2. Again, not to scale, but I'm using the information that I have radius. Again, we have radius everywhere, radii. And then I'm able to use my right triangles for help. So that's where we're going to stop for today. It is, again, just a little bit of information that we will see show up, and especially for whatever reason, and I don't know why, in past, I know that you didn't have to take the EOC this year, but for whatever reason, these questions show up a lot on those standardized tests, so I wanted to make sure that I showed that at least to you today. When we come back on Monday, you will find that we will push forward before Friday. I will answer any questions that you have. I will also post book pages for you. I'll take some PDF shots of those and upload those for you on Circles. And we will come back on Monday to talk about any questions you may have, any assignment work that you'd like to go over. And if not, I will provide this information for you, and we will keep going with Circles. Until then, appreciate if you've watched, but I appreciate more if you are getting all of your work done. You guys have a great day.